Hello everyone, welcome to Cambridge YouTube channel, your only ultimate destination for learning chemistry. I am your host and your tutor Andy Ago, and today I'll be taking you through calibration of UV-Vis. Okay, so the image at the left hand is the UV-Vis and the image at the middle is me at the lab. So what do we mean by ultraviolet visible spectroscopy? The basic principle involves absorption of UV or a visible light by molecules, atoms, or ions which are present in your solution. Now let's look at the working principle of this UV-Vis. I'll divide it into three parts. We have the energy absorption, the transition of electrons, then the quantification of absorption. What do we mean by energy absorption? So the energy absorption stage, it is when a beam of UV or visible light passes through your sample. Now when this happens, some photons in the beam or light in the beam may be absorbed by your molecules, atoms, or your ions which are present in your solution. Now the absorption of light will cause electrons to move from their lower energy levels to a higher energy level. However, note that the transition occurs when the energy of the incident photons matches the energy differences between the electronic states of the molecules. Okay, now what you need to do is the quantification, how much light has been absorbed. So the amount of light that have been absorbed by your sample at a specific wavelength is measured by a detector, and it is being displayed on your screen as absorbance. Additionally, UV-Vis also relies on the Beer-Lambert law. So what does Beer-Lambert law state? Beer-Lambert law states that absorbance, which is represented by A, is proportional to concentration of the absorbing species, the molar absorptivity, and the path length of your solution. This is the cuvette. We have different types of cuvettes, but this is the glass cuvette. Okay, so the path length of this solution is 1500 microliters. 1500 microliters. Okay, so if you are the lab and you are to fill this cuvette, glass cuvette, please don't fill it to halfway. Okay, if not, it will affect your absorbance, because we are saying that factors in which absorbance depends on is the concentration of the absorbing species, the molar absorptivity, and the path length of your solution. Now let's look at how to prepare this solution and calibrate with the UV-Vis. Let's take, for example, our pollutant to be methylene blue. Let's take our pollutant to be methylene blue. So pollutant as methylene blue. I'll write methylene blue as MB. Okay, so methylene blue is a powder sample. So now at the lab, if I ask you to weigh 20 ppm of methylene blue, or to prepare or calibrate 20 ppm of methylene blue, you cannot measure directly the absorbance of 20 ppm methylene blue with this instrument. Therefore, I would like to draw your attention to this specific part. Always note that every analytical equipment has its detection limit. Therefore, before you use any analytical equipment, make sure you know the detection limits of that equipment. In today's video and today's study, the equipment you'll be using is the Thermo Scientific Genesis ultraviolet visible spectroscopy, and this type of equipment has a detection limit of 10 ppm. Okay, it has a detection limit of 10 ppm. So it means that I cannot measure any absorbance above 10 ppm. So what then do you do? Okay, now let's go straight to calibrate. It means that we need to prepare solutions in this range. We need to prepare solutions in this range. to know whether our instrument is working correctly. So we have 0.5, 1, 2.5. You can set your own range. Okay, then we measure our corresponding absorbance. Now what we need to do is we need to plot a graph of absorbance against concentration. And once we do that, we get an equation of a line. Very good. Now let's assume that we are to treat 20 ppm of methylene blue dye. Okay, now to treat this 20 ppm of methylene blue, we cannot measure it directly here. So what we need to do is we need to find what volume can we pick from this, which is the stock solution. Then we determine. Okay, so we can use the formula C1 V1 is equal to C2 V2. Already we know that this equipment can only measure 10 ppm. So we know our final concentration. Then the volume is 1500 microliters, which is 1.5 milliliters. Okay, so we know our final volume. We know our initial concentration, which is 20 ppm. What we do not know is the initial volume to pick. So now initial volume will be C2 V2 over C1. Then now if we are able to pick this V1 from 20 ppm, we dilute it with water into the cuvette. Then we'll be able to measure the absorbance. Now when we measure the absorbance, what we need to do is we will multiply our value by a factor of what? Of 2. If it is 30 ppm, you multiply by a factor of 3. If it's about 40 ppm, you multiply by a factor of 4, and so forth. Okay, so now let me show you how to convert this absorbance also into concentration. So now we are saying that to convert this absorbance into concentration, then you need to compare the Beer-Lambert's law with the equation of the line. So let's write equation of a line as ymx, and let me represent the intercept by the alphabet K. Okay, now with this calibration line, we plotted absorbance, which is A, by concentration, which is C. So it means this becomes our slope. And therefore we do not have an intercept, which implies that anytime when we plot the graph absorbance against concentration, we will have a straight line passing through the origin. Okay, so if we compare absorbance with the equation of a line, then absorbance is proportional to y, then concentration is also proportional to x. Therefore our slope is m and our intercept here is k. What are we interested? We are interested in x, which is the concentration. So let's make x the subject in the equation of a line. So you say x is equal to y minus k all over m. And what is your y? Your y is your absorbance. Your k is your intercept you have found, which is 0.0394. And your m is your slope, which is 0.1903. Okay, then you will be able to determine your concentration. Now this concentration, since it is 20 ppm we were preparing, you just multiply this concentration by a factor of 2. If it is 30 ppm, you multiply it by a factor of 3, and so on. I hope you really enjoyed this video. Please like and subscribe for more videos. Thank you for watching.